Okay, so this is BMQ question 2. We are looking at the angle that OA makes with each of the positive x, y, and z axes. Alright, so if we were to remember now, if we look at the x, y, z axis, we know something like this. Okay, right, this is our x, this is our y, the z axis is just like you're taking your right hand and pointing it towards you, right? And you know that if we were to use, so what we do is we need to deduce that, along the x-axis we can use a vector that lies on the x-axis. So this will help us to be used to find the angle between OA as well as with the x, y, z. Okay, so example for x-axis, right? One example of a vector we can use that lies on the x-axis is 1, 0, 0. So if we want to find the angle of OA and the x-axis, this is the same as if we were to use two vectors. First one is OA, and this is 6, 2, negative 3. The second vector is our x-axis. Okay, it's 1, 0, 0. Right? So we know that you finding the angle between two vectors, and then it's just finding the angle between vector OA and the x-axis is just the same as finding the angle between these two vectors. Right? And we can just use the normal formula. 2, negative 3 modulus of 1, 0, 0. Okay, and this will give us the cosine of the angle between OA and the positive x-axis. Alright, so going on, if we were to go and continue this, you know that let's say if we cosine theta, alright, and we want to use 6, 2, negative 3 dot product with 1, 0, 0, and the modulus below will give us 6 square plus 2 square plus negative 3 square modulus with 1 square plus 0 square plus 0 square. Now the numerator will just give us probably 6 and 1, 6, the rest will give you 0, and this will, the denominator will give you 7. Alright, and so since you know that the angle, cosine of the angle between OA and the positive x-axis is 6 over 7, and you know that this theta is a non-reflex angle, so it can only be in quadrant 1 or quadrant 2, okay, because by definition this theta between the two vectors is a non-reflex angle. That means it has to be less than 180 degrees. Okay, that means it can only be in quadrant 1 or quadrant 2. So since this is positive, okay, theta has to be in quadrant 1. Alright, and you know that from here, from principal angle, theta just equals to cosine inverse 6 over 7, and rounding off to one decimal place, this will give you 31.0 degrees. Alright, now similarly, if you were to go back and we try to find the angle, I use a different pen now, different in color, vector OA and the positive y-axis. Now we know that for the y-axis, right, we can also use a vector that lies on the y-axis. For example, 0, 1, 0. Where 0, 1, 0 means 0 units in the x direction, 0 units in the z direction, 1 unit in the y direction. Of course, this is not a unique vector we can meet. We can either use 0, 2, 0, we can use 0, 3, 0. Any vector is fine. Okay, I'm just going to use the simplest one of the smallest number, 0, 1, 0. So the angle between OA OA and the y-axis. Okay, suppose let me call this maybe beta. Alright, and we know that based on formula, cosine of beta, this is equals to OA scalar product with y-axis which is 0, 1, 0, modulus with, again, what we have just now, 6 square plus 2 square plus negative 3 square modulus of 1 square. Okay, and that will actually give you, by own calculation, you should get 2 over 7. Okay, again, we know that beta, the angle between two vectors, is a non-reflex angle, meaning that it can only be in quadrant 1 or quadrant 2. Right, by definition, this is a unit angle. it can only be in quadrant 1 and quadrant 2. So therefore, you know that since quadrant 1 and quadrant 2 and cosine is positive, quadrant 1, quadrant 2, cosine is positive. So what quadrant can it be? It can only be the first quadrant. So beta lies in quadrant 1. Alright, and from there you can straight find the answer, and beta is just nothing but cosine inverse of 2 over 7, which gives you 73.4 degrees. Alright, and for the last one, we're going to go back and we see that we are going to find the vector angle between vector OA and the z-axis. Oh, that's easy. Again, now let me use a different color. Now z-axis, I'm going to use another vector that lies on the z-axis, which we can use 0, 0, 1. Okay, again, this vector is not unique. Okay, so 0, 0, 1. So let me call this, let the angle between OA and z-axis be, say, gamma. Alright, and cosine of gamma, again by formula we use the two vectors that help us, which is just the scalar product of OA and 0, 0, 1 together with the modulus of OA again. Okay, and the modulus of 0, 0, 1, and this should work it out to give you negative 3 over 7. Now, considering that your cosine is negative and your gamma has to be in quadrant 1 and quadrant 2, alright, so what can gamma be? Gamma have to lie in the second quadrant. Okay, so this means that since cosine gamma is negative, gamma has to lie in the second quadrant. Alright, it cannot be in quadrant 3 or quadrant 4. Very simple, because by definition we know that the angle between two vectors, it has to be between 0 and 180 degrees. Alright, it cannot be, it's a unit number. We do not have a it's a non-reflex angle. Alright, okay, so because it's quadrant 2, so how do we find our gamma? Gamma is actually, you know that it's actually quadrant 2. That means your gamma looks like this. Alright, and this is so-called the principal. If you remember your Sec 3 or J3 math, this is the principal angle. So gamma is 180 degrees minus the cosine inverse, alright, finding the principal angle, 3 over 7, alright, and your answer will work out to be 115.4 degrees.